Okay, so let's talk about functions a little bit. Some of these things, hopefully you've seen a little bit. It's going to be a little bit of review. There's going to be a little bit that will be different. I'll try to help you out through this. Okay, so terminology. Okay, a relation versus a function. So notice that everything is the same up in here. Okay, again, the domain is the inputted set, and the range is the output. The domain is the x values, and the range is the y values. So a relation is a pairing of a member of the first set to any number of members of the second set. And a function, exactly one. So let's look and see how that makes these things different. So when we say pairing, we're saying we're plugging in a x value and we're pairing it with a y value. So the pairing here is that we're pairing this number right here to that one. So how many numbers did we pair to this one number in the domain? We paired one. We paired one. We paired one. So this would be a function. Now here we got an output. We got two different outputs. We paired two different outputs with that input of 1. So at any point in there, if that happens, it's not a function. So it doesn't have to happen for every value. If you have any number, if you have more than exactly 1, if you got 2 for any one of the domains, then it messes it up for the whole relationship, and it's not a function. So we could call it a relation, but it's not defined to be a function. Okay? Function, yes or no? Yeah. Pairing one value. Okay? So you could think of that. So there's one output for each input. So that's a function. Is there one output for each input? No. That value of 4 has two different things assigned to it. This value of 7 has two different values assigned to it, so that would not be a function. So how am I making, I just threw these random numbers in here. I didn't make any particular order or random, there's just total randomly chosen numbers, but the relationship between the sets is what makes something a function or a relation. Now, if I made one up, let's say that I made up a rule, and I said the rule is this: y equals plus or minus x. And let's say that I threw in some values for x. Let's say I threw in a 2 for the x. Then the y is equal to the positive x, and the y is equal to the negative x. So we are always going to have two different y values for each value of x in this particular rule that I just kind of made up. So this would not be a function. Okay? The domains and ranges aren't defined, but it would be an example of not a function. Okay, let's turn to the next page. Now, these are examples of ordered pairs. You could put them into a table format. It's the same thing. 2, 1, 3, 2, 4, 3, 9, 20. That would be an example of function however you wrote it. So that's a function. Because each value of the domain is assigned exactly one member of the range. We're not assigning two different values of the range to this x value, or this x value, this x value, this x value. Are we here? Yes. We're assigning this value to the 3 and this value to the 3. So that is not a function. Okay? So let's talk a little bit now about relations and some kind of things that we might do with relations. So it says, consider the relation given as follows. So they named it H. Okay? So if we want to talk about the inverse, well, it's not too tough. Just switch the x's and y's for every set or for every ordered pair in the relation. Just switch the x and the y. Okay? So interchanging the first and second coordinates of each pair in a relation produces the inverse relation. If a relation is defined by an equation, interchanging the variables produces an equation of the inverse relation. So here you switch the x's and y's in the ordered pairs. Here you actually switch the x and the y in the rule, the equation. So real simply, find an equation for the inverse. X equals y squared minus 2 times y. Okay, let's take a look at the next page here. So now we're going to talk about a function being one-to-one. Now the notation here is a little bit messy, and we'll try to get through it. We can talk more about it when I get back, but we'll see if we can get through this. Okay, a function f is one-to-one if, when the outputs are the same, the inputs are the same. So if you were to have something that had the same y values, then to be one and one, they'd have to have the same x values. So you start with this and you try to show that x values are going to be the same if we know that the y values are the same. Okay? So that would mean that it would be a one-to-one function. Okay, so now in your assignment, and I'll maybe go through one the other way too, but in your assignment you have something where they want to show you that it is one-to-one. This example, they're trying to show you that it's not one-to-one. Okay, so I'll show you how to do that. So, using the definition, okay? So let's take f of a and find out what it equals. So f of a would equal, in this case, 2 times a squared plus 3. That's f of a. So we're assuming that this is true. We're assuming that f of a equals f of b. Now f of b, if you plug b in, is going to be 2b squared plus 3. Now we're trying to show, if we wanted to show that it was a function, we'd show a is equal to b. We're actually going to try to show that a is not equal to b, because we're trying to show that it's not one-to-one. So you're looking at that and you're probably thinking, well, gosh, a would have to be equal to b. Well, it doesn't. Okay, let's talk about this. Okay, so I'm going to subtract 3, and I'm going to divide by 2, and now I get a squared equal to b squared. Well, if you're trying to show that a rule doesn't work, then come up with a counterexample. So I'm going to try to find a value for a and a value for b where this is true, but a isn't equal to b. Well, positive and negative. So if I let, and I'm going to write this, and I wouldn't mind if you wrote this, I'm going to let a equal 3 and b equals negative 3. And I'm going to show you that, hey, 3 squared is 9, and negative 3 squared is 9. So does a have to equal b? No, a didn't have to equal b. Okay, so you start off with a being plugged into f, b being plugged into f, and say we're saying that these are equal. Does that mean that a has to equal b? No, you find a counterexample. You try to explain to me that you know that if this is opposite, that this is not going to make it true. Okay, so a doesn't end up being equal to b. Okay. Now, if you look at your assignment, okay, if you look at your assignment on page 401, there's one in there that I want to have you take a look at. Okay, so I'm just going to kind of create a blank page here and we kind of look at one. So page 401. So number 18, it says given function f, prove that f is one-to-one. Show that it is one-to-one using the definition. So on 18, start off with f of a equal to f of b and end up with No counterexample, A equals B. Okay, so 18. So what would f of A equal? Well, hopefully you understand that when you plug A into the function, and again, I'll rewrite the function here. The function is f of x equals 4 minus 2x. So f of A is going to be 4 minus 2a. F of B is equal to 4 minus 2b. So there's not a squared there, so we got a little different situation. Again, what I'm starting with is this, and I'm trying to show that. I'm trying to show it. I'm trying to show that it is 1 to 1. So I'm going to subtract 4 and divide by -2, and I got A equal to B. So if this is true, this has to be true. There is no counterexample for it. Okay, so that's the algebra behind showing that a function is 1 to 1. Now, 1 to 1, there's another name for it, and you maybe heard of it this way, and you maybe understand this a little bit better, is if it passes the horizontal line test, it's 1 to 1. So we're going to look at horizontal line test now a little bit. Okay, if it is possible for a horizontal line to intersect the graph of a function more than once, then the function is not 1 to 1. Now, this test is used to determine if the inverse is a function. So notice it says here that if it is not 1 to 1, then the inverse is not a function. So again, let's just kind of try to see here, do we have a horizontal line that passes through this in more than one place? Yeah, we got lots of horizontal lines that are going to intersect this graph in more than one place. So it is not a 1 to 1 function. And its inverse is not a function. So this thing has an inverse, but its inverse is not a function. Okay, so let's take a look at the next page here. So it says, from the graph shown, determine whether each function is 1 to 1 and thus has an inverse that's a function. Does this pass the horizontal line test? Yes, so it is 1 to 1. So determine whether there's 1 to 1 and has an inverse as a function? Yes. No, it does not pass the horizontal line test. So it does not have an inverse that's a function. Yes. Now, so like this guy is just barely going up, but it's not going up at a spot where we can hit the graph in two places. Again, going up real slowly, but you can only hit it in one place. So this is a graph that is 1 to 1. And here you can see that it hits in two places. Lots of places. Maybe if you can draw right here, and it hits in 3 places. Okay, might be worth looking at the rule again. If it's possible for a horizontal line to intersect the graph of a function more than once, then it is not 1 to 1. So we're looking to see if it's 1 to 1, it's in more than one place, so it's not 1 to 1. Okay, so now we're going to get into a little bit of algebra. Okay, so there's going to be some questions where you have to answer these questions, and then there's going to be some where you have to maybe do a little bit of algebra. Okay, so if the inverse of a function is also a function, so if it passes a horizontal line test, we're going to try to come up with the inverse, and that's called F inverse. Now, when we see that -1 up there, we like to think of that as an exponent, but it's not an exponent in this notation. Okay, it stands for inverse. That negative stands for inverse, but it's not an exponent. F of -1 does not mean the reciprocal. Doesn't mean reciprocate. That's what negative exponents mean. It's just a symbol. Okay, so don't do any reflecting. Don't do any flipping. That's what you would have done if you had, for example, like 2 to the -1. That would be 1 over 2 to the first. Okay, but that's not what this is. This is just the symbol to represent inverse. So we say this, the inverse of F. So we're going to try to find some inverse functions. Okay, so if you remember, all you have to do is switch the x and the y from the first page to find your inverse. That's what you're going to do here. So we're going to try to find the inverse of this. Okay, so if a function f is 1 to 1, the formula for its inverse can generally be found as follows. Replace the f of x with y. Interchange the x and the y. Solve for y. And replace the y with the symbol for inverse, the inverse of f of x. So if you want to write that down, you can. We'll talk about how to do this problem and some others. Okay, so let's talk about what inverse is. Without any rules here, let's just kind of look at some things. So like if I told you that function h is the doubling function, well, what's the inverse of that? What's the opposite of that? Dividing by 2. So symbolically, it would be x over 2. They undo each other. They're opposite functions. Okay? If I told you that k of x was add 1, then the inverse of k is subtract 1. That's all we're doing. We're trying to find the function that undoes what the first function does. Okay? So let's see if we can follow the rules and see if it makes any sense here. So rule number 1, replace the f of x with a y. That's step number 1. Okay, so again, we do know we're assuming this is 1 to 1 and it has an inverse that's a function, so let's find it. So that's step 1. Step 2, interchange the x and the y. I like to draw a line because this function is the inverse of this function. So we've kind of crossed into making the inverse. So this is the old function. This is the inverse of the old function. Solve for y. So here, we're going to solve for y, and you got to do it in the right order. Remember, get rid of the weakest stuff first. Add 3. Write down what your result is. So it's x plus 3 equal to 2y. Now divide by 2, the whole left side and right side, and you end up with x plus 3 divided by 2 equal to y, or y equals x plus 3 over 2. So we're done. That. Now symbolically, let's replace the y with the inverse notation. So the inverse of f, take out this, replace it with this, and keep that right side the same. So let's look at this. This is the function doubling and subtracting 3. Well, what's the opposite? What are the inverse relationships of doubling and subtracting 3? Adding 3 and divided by 2. Now it is the inverse. Okay? So let's have you, I'm going to give you a minute to see if you can try finding the inverse for g of x. So see if you can follow the steps and see if you can find the inverse of g. Stop the recording if you need to. It's up to you guys. Now, the inverse of cubing is cube rooting, so you might not be 100% comfortable with that yet, but the cube root, just throw the cube root over the top. Okay, leave the left side, cube root x plus 2 over 3 equal to, what, the cube root and the cube undo each other, so you just have the y there. Okay, so your function is going to be inverse of g equal to the cube root of x plus 2 over 3. And just leave it like that. If your answers are off a little bit in how they look on Monday, that's okay. So open up your book, page 401. And looking at your assignment, they do ask you to graph. So you're going to use Desmos. So like if you looked at number 33, it says graph the function. If you need to graph the function, graph it. If you don't need to graph the function, don't graph it. For example, 33, that's a linear equation. So that's going to pass the horizontal line test. Okay, so if you need, type that into the calculator, and that will help you decide if it is one-to-one and has a inverse that's a function. Okay? All right, good luck.